On December 26, 2004, a magnitude 9.1 Great Subduction Zone earthquake struck off the coast of Sumatra. Sumatra is the fifth most populated island in the world, and the bulk of the population lives at sea level. The earthquake was felt by more than 20 million people. Immediately following the earthquake, a tsunami swept coastlines across the Indian Ocean for over 9 hours. The long-term lack of finances in developing countries and the lack of strict building codes results in using cheaper materials in vulnerable locations that can be prone to collapse during strong ground shaking and during the surge of tsunami waves. Residents and the scientific community were caught off guard because there hadn't been a great earthquake in the region for over 140 years, and there was no historical precedent for such a far-reaching tsunami. Because of that, there was a history of inadequate tsunami education for evacuating low-lying areas in the event of a large earthquake and few warning systems in place. More than 227,000 people died and 2 million were left homeless, prompting the largest emergency response in history. In the 30 years prior to 2004, there were 1,500 earthquakes greater than magnitude 5 that were evenly spread across the length of the Sumatra subduction zone. None exceeded magnitude 7.9. Two great earthquakes documented in the 1800s included the 1833 magnitude 8.9 earthquake and the magnitude 8.5 earthquake in 1861. Both produced tsunamis that took thousands of lives in nearby coastal areas. Three other major quakes in 1847, 1881, and 1941 had no record of significant tsunamis. Like this 2004 magnitude 9.1 earthquake, all earthquakes greater than magnitude 9 worldwide have been megathrust events that occur when one plate dives beneath another. Only two recorded quakes were of greater magnitude, the 1960 magnitude 9.5 Chile and the 1964 magnitude 9.2 Alaska earthquakes. The 2011 Tohoku Oki earthquake was also magnitude 9.1. All four produced destructive tsunamis, although fatalities and damage from the 2004 tsunami far exceeded those caused by tsunamis that were generated in Chile, Alaska, and Japan. If we look at a simplified view of the tectonic setting around Sumatra, we see the oceanic Australian plate diving beneath the Eurasian plate. A closer look shows a more complicated picture. Off northern Sumatra, the oceanic India plate is being subducted at a rate of 45 millimeters per year beneath the Sunda plate, where a smaller Burma microplate has formed. In cross sections, we see the microplate locked to the subducting India plate. The 2004 Sumatra earthquake occurred as the result of thrust faulting on the interface between the two plates. The event was initiated at 30 kilometers depth, and the megathrust boundary ruptured northward for a duration of almost 10 minutes. The leading edge of the overlying plate lifted the seafloor by several meters, producing a tsunami with run-up heights along nearby coastal areas of almost 30 meters. Over the next 9 hours, it would cross the Indian Ocean and would take lives in 14 countries. Over 240 aftershocks greater than magnitude 4 were recorded. A significant slip continued for over 1,300 kilometers based on teleseismic and regional GPS data. Many of these aftershocks may have been triggered on faults in the overlying Burma microplate above the thrust fault plane. The proposed rupture length, longer than the state of California, has also been compared to the length of the Cascadia subduction zone, another area with a history of great earthquakes. Some had expected and even feared that historically small, isolated Aboriginal tribes of the Andaman and Nicobar Islands might have been wiped out by the onrushing 2004 tsunami. Oral traditions developed from previous earthquakes, however, prompted tribes to evacuate lowlands before the tsunami arrived. For example, the folklore of the Anj tribe speaks of huge shaking of ground followed by high wall of water. Almost all the Anj people fled to high ground within minutes of feeling the earth shake. Unfortunately, 2,000 people still perished on the Andamans when the 10-meter high tsunami surge washed on shore. The Indian Ocean Tsunami Warning System was established by UNESCO within months of the 2004 tsunami to alert coastal areas as quickly as feasible. Many at-risk populations, locals, and tourists now practice evacuation procedures, greatly reducing the level of risk.